Hi everyone, I'm Dr. K. Vijay, Assistant Professor in the Department of Civil Engineering at K.S.Rangasamy College of Technology, Tiruchendur. Today we will be studying the design of a retaining wall and essential structural components used to support soil and prevents slope failures in civil engineering projects such as highways, bridges, basement and embankments. In this unit, we will cover introduction to retaining wall, types of retaining wall, components of retaining wall, earth pressure and forces acting, structural requirement, design of cantilever retaining wall, design of counterfort retaining wall, and let's start the understanding what is the retaining wall is and why it is used. A retaining wall is a rigid structure designed to resist lateral earth pressure and to retain soil or other loose materials or different level on either side of it. The main functions are to hold back soil and create a vertical or near vertical change in ground level, to prevent slope failures, landslides or erosions, to provide usable level space to road, bridges, railways, basement, etc. To support embankments and to protect against score and near water bodies. Uh, what is main forces acting on the retaining wall includes a larger earth pressure, which is active pressure with triangular distributions, self weight of the wall, weight of the soil on the heel, which aids stability, surcharge load from traffic, building or stored material, hydrostatic pressure in groundwater is present, seismic lateral force in earthquake prone areas. Sustainable requirement that must be checked in designs are overturning. Resisting moment must be greater than overturning moment. The factor of safety should be less than 1.5 to 2. Sliding resistance force must be sliding force. The factor of safety should be 1.5. A bearing pressure, maximum pressure on the soil should be greater than or equal to self-bearing capacity. Structural safety, stem and base must resist bending moment and shear. The functions of the retaining walls are retain soil at a different ground level, prevents soil erosions and sliding, prevents lateral support in earth masses, ensures stability of slope and embankment, ensures protect nearby structures such as roads and buildings, provides lateral support to the earth masses. Common applications includes fill road cutting, bridges, approaches and abutment, base construction, uh, canal bank and waterfronts, highway embankment. Some of the types of retaining walls. Retaining walls are classified based on the construction methods and structural behaviors. Main types are gravity retaining wall, resist earth pressure through self-weight made by the masonry of the concrete, used to small height. Cantilever retaining wall made of reinforcement concrete consists of a stem and base slab, most commonly used. Counterfort retaining wall, similar to cantilever but with triangular support, counterforts used for the larger heights. Shear file retaining wall, a thin flexible wall used in the soft soil and the waterfront. Anchored retaining wall support by anchoring and tie backs used where the space is limited. The counterfort retaining wall, similar to the cantilever wall, provides the counterfort triangular support user for the larger height. Sheet pile retaining wall, which is thin flexible wall used in the soft soil and the waterfront. Anchored retaining wall supports by anchor or tie backs used where space is limited. Um, some of the assumptions in the retaining walls. The following assumptions are commonly used while designing the retaining wall. The backfill soil is homogeneous and isotropic. Soil is dry in a uniform moist. Backfill surface is horizontal. Wall face is vertical and smooth. Earth face is active earth pressure like Rankine's or Coulomb's theory. Effect of cohesion is neglected for granular soils. Groundwater tables is below and base slab. These assumptions made analysis management and are based on the structural earth pressure theories. A typical cantilever retaining wall consists of stem, whereas vertical and inclined wall retaining under resistance lateral pressure, base slabs, heels and toe and shear keys. These are all the forces acting on the retaining wall. A retaining wall is subjected to the following forces: active pressure, which is PA, horizontal pressure from back soil acts at h by height by divided by 3 from base, self weight of the wall, weight of the stem based on the counterfoot, if any, weight of the back soil, soil resting on the heel adds to the stability, surcharge load due to vehicle structures or storage, as water pressure, it in groundwater is present, increasing the overturning moment. A retaining wall must satisfy the three main stability checks. Stability against sliding. Wall should not slide along base. Resistance comes from friction and shear. Key. The factor should be 1.5. Stability against overturning. Wall should not overturn about toe. Resisting moment, overturning moment. The factor should be 2. Stability against bearing capacity failure. Soil pressure under base must be within safe bearing capacity and no tension should be developed. A cantilever retaining wall is a reinforced concrete wall that acts like a cantilever fixed at the base. It resists earth pressure using weight of the wall, weight of the soil on the heel slab. The main features are economical up to 6 meter height, consist of stem, heel and toe. Widely used in highways, buildings and embankment. How it works? So earthquake pressure causes bending in stem. Heel slab provides stability moment. Toe slab resisting the bearing pressure. This is all the step-by-step procedure for the design of, for cantilevering retaining wall. Preliminary dimensions should be estimated height. Base width should be 0.5 to 0.75 into height. Heel of under toe proportions. Earth pressure calculations used Rankine's theory to find active earth pressure and its final applications. Stability checks sliding, overturning, and bearing pressure. For structural design, designing stem for bending moment and shear, um, designing heel and toe slab, detailing, reinforcement detailing, and drainage provisions should be provided. Um, A counterfort retaining wall is a modified form of cantilever wall with thin triangular reinforced concrete webs. Counterforts provides regular intervals on the back side of the wall. Purpose of counterforts reducing bending moment in stem and base slab. Act as a tension members tying stem and base together. Main features are economical for heights greater than 6 meters. Spacing of counterforts are 0.3 H to 0.7 H, used where earth pressure is very high. These are all the design steps for the counterfort retaining wall. Preliminary proportions, earth pressure calculations, stability check, structural design, and detailing and drainage. In summary, retaining walls are a critical structure used to retaining soil structure and slope stability. Some key takeaways are: understand types, components, and forces. Always check stability against sliding, overturning, and bearing. Cantilever wall are suitable for height up to 6 meter. while counterfort walls are used in the greater height. Proper drainage and detailings are essential for long-term performance. I hope this session provides a clear foundation for the designing of retaining wall. Thank you for your attention and thank you.